or I'm sorry, birds and bats have in common? Go ahead.
They have wings.
They have wings. Go ahead. They both eat insects. They both have wings. They both, okay, so wings, right? Okay. Now, what do they not have in common? Go ahead, John Jason. Bats are nocturnal. Okay. Are there any birds that are nocturnal? Owls. Okay. So that's a little similarity, somewhat. Feathers. Okay. So birds have feathers. Bats have like fur.
Yeah, I was about to ask. I was thinking. I wonder what do bats have.
Okay. They have like some type of fur. Go ahead. Birds lay eggs. What bats? Bats have
That's why bats are mammals.
Bats are mammals. Yeah. Okay, you got something else? Okay, so do you see how this Venn diagram is set up? What they share, it's crossing over. What they don't share is on their own separate little like bubble. That makes sense? Okay, so that's kind of how Venn diagrams work. On your paper, I would title this sample space, sets, subsets, and you can just stop right there. I know. Sample space, it's up on the board. Sets and so. Event is a set of one or more outcomes in a chance experiment. Okay. Probability is the probability of a chance event is a number from 0 to 1 that expresses the likelihood of an event occurring, with 0 meaning it's not ever going to happen and 1 meaning it will always happen. Okay, so what's the probability of the sun coming out tomorrow? 100%. Okay, without like Armageddon and like all the other,
The sun existing.
Yeah. Okay, like we know sun's gonna get up tomorrow, right? Okay, so that's 1 or 100%, right? Okay, what's the likelihood of it raining normally? 50, because it's either gonna rain or it's not gonna rain. Yeah. It's kind of like heads or tails, right? Okay. Now, sample space is the list of every possible outcome from a chance experiment. Okay, so it's all your potential outcomes. So for instance, if I flip a coin, I will either get heads or I will get tails. That is my sample space, heads and tails. Wild, I know. Okay. Go ahead and write down those definitions. You can shorthand them if you want. About one thing. How many of y'all have seen a die before? Like a little, like a die dice. Okay. All right, cool. No, that's not what I'm talking about. A die. D-I. That's spelled the same. Okay, so remember, if I talk about dice, how many sides does that have? 6 sides. Okay, great. We're already starting off on a good start. Okay. So each of the spinner spun once. Okay. Who's calling me? I don't know who this is. Okay, each of the spinners spun once. Okay. Here are the possible outcomes represented as a tree diagram. For some reason on the SAT, they always put a tree diagram. It's always stupid, but it's fine. Okay, so really quick, on this first one, they've got A and B, right? And then you potentially could have another spinner land on M, L, or N. And then you could potentially have another spinner on W, X, Y, Z. So a tree diagram kind of gives you like all the possible outcomes. Okay, so in total, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24 outcomes that could potentially happen in this scenario. Does that make sense? Did everybody see where I got those from? Yeah. I took the ends and I counted them up. You could say like 4 times 6. You could try. So here it is again. We got 3 spinners. We got 1, 2, 3. We spin the first one. We could either get A or B, right? Okay, so we're gonna have A or B. Yeah. And then on the second spinner, we're either gonna have L, M, or N. So we got L, M, N on both of these. Does that make sense? Okay, and then for each one of those, we have W, X, Y, Z. So does that make sense? These are all the possible outcomes that we could potentially have, right? Huh? Say again. Right. Yep. Okay, so here is also a table that represents this scenario. So notice how we have W, X, Y, Z, and then we have AL, which is A, then L. We have AM, AN, BL. You can make a table, you can make a tree, you can do just like a little diagram of the spinners. Those are different ways that we can represent it. Okay, so how many outcomes are in the sample space for this experiment? How many did I tell you? There are 24. Okay, so if I were you, I would take a second, go ahead and draw these 3 spinners on your paper so that you can come back to these notes. So we already talked about how there are 24 potential outcomes, right? Okay, when spinning all 3 spinners, what's the probability that they point to any letters? I'm sorry, to the letters A and Y. Okay, so what is the probability so that they point to the letters A and Y? Okay, so coming back to our little chart, over here, how many times do you see A and Y in this little table right here? 1 time, right? Okay, so you see it right here. Out of how many total times? Okay, so we are a probability of 1 out of 24. So if we go into our calculator and we type 1 divided by 24, we get 0.04, which means that we have a 4% chance of this happening. I would definitely write this down. What? I do not. Are you okay? Are you profusely bleeding? No. Do you need to go to the clinic or no? Okay. So why are the bleeds? I just work here. I just work here. Okay. Now, if it points to AMW, ANZ, or BNW, okay, I'm gonna write those down. AMW, ANZ, or BNW. Sorry, I almost wrote BMW. Okay. If I look at my little chart again, okay. If I look at my chart again, I see AMW on here, right here, ANZ right here, and BNW, which is right here. So, no, not BMW. No, not the car. Okay. And how many of these do I have? 3 circles out of how many in total? Okay, so 3 divided by 24, which we could simplify to 1/8. And when we go into our calculator and we divide that, that's going to give us 0.125, which is 12.5%. If a 4th spinner that has 2 equal sections labeled S and T is added, how would each of the methods need to be adjusted? Okay, so I'm going to go back to this little tree. I'm going to hit clear and then I'll put them back in just a second. Okay, so coming back in here, you see our little tree diagrams? Okay, if we added another spinner and we were like ST, that means that we would have all of the, yeah, I'm not writing all these up. What? 24 multiplied by 2, right? Okay, so 24 multiplied by 2 is 48. So there would be 48 possible outcomes. There we go. Okay, so there would be 48 possible outcomes, right? Okay, 48 outcomes, and that would change all of these percentages, right? Because now it would be 1/48, which is an even lower chance of happening, right? Okay. Yeah, 2%. Okay, same thing with this one. Be 3 out of 48, and that would be 6.25%, right? Okay. Okay, so what did I do? I added another circle. I added another spinner, which means that I took 24 of my outcomes and multiplied it times 2. So that means I'm going to have 48 outcomes. Okay. it's gonna take all of my percentages that we just found and then divide them by half. Because now it is less likely to happen because we have more outcomes. Paris said, well, what if there's going to be 3 equal sections? What would we multiply it by then? 3. So we would take 24 and multiply it times 3. Okay. And that would change the number of outcomes. Okay. So let's go ahead and look at this next part. Take a second and go ahead and write out A, B, and omega. That's what this actually is called.
Oh, yeah. Oh, yeah.
Okay, take a second, write out all of this notation, and then we'll talk about it. One thing that you need to know about mathematicians, they like to make everything super fancy. We like to create our own like language and like
That's so cute.
numbers. We like to sound important. So we use confusing notation to confuse the rest of the world. That's all we do. Okay, so really quick, when you see like these little weird symbols, it's probably a Greek letter that means some type of set. Okay, this is, hey, the set omega. Okay, omega. Everybody say it with me. Omega. There we go. Fantastic. Okay, now, ready? Okay, so the upside down symbol, it looks like a little like arc, a little rainbow, right? Okay, this is the intersection. Okay, the U is called the union. And the little like, I don't even know what it's called, apostrophe. Yeah. Is the complement. Okay, it's like saying everything not. It's like opposite day with compliments.
Hmm?
Yeah.
So,
It's like insults. Yeah, yeah. Same thing.
That's so interesting.
Yeah, that's cute.
That is
I like
so-
it. Okay, so you ready?
Oh, wait.
Okay, so intersection is what happened on this first one. Okay, so we're looking at number 1.
So you said you drew a non.
The intersection. Okay, what does it mean by intersection? Like where they cross, right? Like where they overlap, right? So like when you think of a red light, that's like an intersection of one street and another, right? Okay, so we're looking at A and we're looking at B, all right? We're looking at A and we're looking at B. Where do they intersect? What numbers do they have that repeat? Okay, I got 2 and I got 6 and 7 and that's it, right? Okay, the way that I write this out is I say little bracket. Okay, it's like a little squiggly bracket. Mine looks like trash. I'm sorry. I don't know the real actual word for it. Okay, and I'm gonna write out all the numbers that I just highlighted. So 2, 6, 7, squirrely bracket. Okay. Okay, on number 2, we got the union. Okay, when 2 people get married, they're uniting their life, right? Okay, so all their baggage and all the other person's baggage, they all come together, right? And then they go to the Dr. Phil show. Okay, so what's gonna happen is we're going to write out all of the numbers that are included in A and B. Okay, so we're gonna write all the numbers out from A to B. If they repeat, you only write it once, okay? Because if we're gonna say that both of them are really crazy and loud, we're only gonna say it one time. Does that make sense? Like if the husband and the partner is like both crazy, you're only gonna say that that couple is crazy, right? Okay. Yes.
So every number 1 through 9 besides 5.
Exactly. So 1, 2, 3, 4. We don't have a 5. We got a 6. We got a 7. We got an 8. And we got a 9. That's a lot of baggage. They go into Dr. Phil.
No.
Divorce court. Okay.
That's great.
Yeah.
That's so depressing.
You're not the father. Okay. Yes, we will. We will. This will be part of it though. Okay. Now number 3 is my favorite. Because like I said, it's like saying like something and then being like, ha, not, or like psych, right? Okay. So what this is saying is take everything that's in A, not, okay, so look at A. We got 1, 2, 3, 6, 7, 9. What numbers are we missing? 4, 5. I miss 8. And 8. Okay. Does that make sense? One's in here. Okay. That's everything that's not in A, but that is in one of the sets that's listed. Okay. Does that make sense? Okay. So again, the little apostrophe that's outside is like, haha, not. Okay. Thank you, Jared. Okay. Yes, ma'am.
So everything that A and B do not share.
Everything that's in A or B, but they don't. Like,
Yes.
that's not in A. Yes.
So that everything that's in
The union is everything that they have together. Yes. Okay. Now, number 4 is a little tricky to read. Okay. All right, ready? We always start with what's inside the parentheses. So we have A intersection of B not. Okay. So let's look back up here up at the top right here. Remember how we said A intersection of B and we listed out 2, 6, 7? We're going to not include 2, 6, 7 and write out the rest. It's everything
In
else.
my brain, it's like you're complimenting one letter, not the other. That's why you're leaving it
No, this is, hey, everything they have that's crossed over, not.
Yeah.
Okay, so that's gonna be 1, 3, 4, 5. Those is really difficult to do. 8 and 9, right? Some backstory. This is a manager that owns 3 local area car maintenance garages with researching certifications on mechanics that work for her company. Consider the Venn diagram. Okay, so there's 3 certifications that these people could potentially have, right? Okay, so you got the certified brake certification, certified AC repair, and certified engine tune-up. Those are the 3 different types. Okay, where they cross over is when people have both of those certifications. So for instance, what's this saying right here is that there are 2 people who have both the certified brake and the engine tune-up. What this is saying is that they have all 3. Okay. It kind of tells you the number of people that have it. Right. So, for instance, how many mechanics work for her company? Well, if I do 4 plus 1 plus 3 plus 2 plus 2 plus 3 plus 3, how many mechanics are there?
6 plus 3 plus 3.
Okay, I'm gonna take your word for it because I didn't actually.
9, 11, 13, 14, 16.
Okay.
18.
Bro, that's a zero. Bro, you were struggling. Okay, ready? Okay, so how many of the mechanics are certified by ASC who works on brakes?
4.
Okay, so this is the part that's an issue. Okay, so we've got 4 people who only have the ACE certified brakes. We also have 2 that both have these. And we have 2 that have all 3. And we have 1 that has 2. Okay, so that's going to be 9 people who can actually work on brakes. Does that make sense?
Yeah, it's not hard.
All right. So how many of the mechanics are certified by ASC to do brakes and tune-ups?
Who knows?
Okay, so here it is again. All right, ready? Okay, so, okay, without y'all saying numbers, because that just confuses people. Hang on one sec. Ready?
21.
Okay. So to do brakes and tune-ups means that it has to overlap, right?
Yeah.
So you got 2 right here, but you also have 2 right here. So how many do you have? 4. 4 people that have both of those certifications. Does that make sense? Like, this is like when you're making a list of the person that you potentially might date, you'd be like, okay, he gotta have this color eyes, this color hair, this okay.
Personality standards.
Yes. Now, how many of the mechanics are certified by ASC to do work on either AC or tune-ups? So that means that when we come in here, we're going to pick all of y'all are killing me. Okay, we're gonna pick all of the ones that have AC or they have the tune-ups. Okay, so that's gonna be all of these people.
Oh, 11.
Okay, so that's 3 plus 3, 6, 8, 9, 10, 11.
No. I know the basic one.
Okay.
Okay.
Now, how many of the mechanics have their certification in brakes or AC, but not in tune-ups? Okay, so here it is again. We got brakes or AC, so brakes or AC, but not in tune-ups. So they can't be touching this circle. So it's going to be these 3.
8.
So that's going to be 8.
Here?
Does that make sense?
Yeah.
Okay, so even though they're adding more to it, it's not complicated. You just gotta focus in on what are they actually asking you for. I'm gonna be honest, I use color when I do this. Like, I do exactly what I'm doing up on the board. I highlight or I draw or I circle and then I start back over. Okay, that might help some of you. Okay, ready? What is the probability that a mechanic selected does brakes and tune-ups? Okay, so how many total mechanics do I have? 16, right? Okay, so I got out of 16, how many does brakes and tune-ups?
Not 16.
Okay, so 4 out of the 16, which if I do 4 out of 16, that's going to be 1/4, which is
25%.
25%. Does that make sense? So when I ask for probability, I need you to give me a percent or a simplified fraction. Okay.